We're going to start by looking at the three-dimensional coordinate system. Now, for three-dimensional space, we add an axis called our z-axis. Now, it's normal to have the z-axis pointing up, and that would be the positive z direction. In order to know where your y and your x goes, we can use the right-handed coordinate system for that, where our right hand, our thumb points up, our fingers curled from the x-axis towards the y-axis. So hopefully that makes sense. Now we also can see our three-dimensional space in terms of planes. So we've got 8 regions called octants that are divided by 3 perpendicular planes, the xy plane, the yz plane, and the xz plane, which you can see in this diagram. So let's start by plotting points in the three-dimensional coordinate system and also identifying points in the three-dimensional coordinate system. So to start with, let's look at point E, which is down here, and let's find the coordinate for that. So our first step, well, you could look at X and Y first, but I'm going to look at this length here. That's representing my Z. So I need to get my ruler out and measure that length, then come back to my z-axis and go, well, what is that length on my z-axis? And you realize that the distance from 0 to -2 or 0 to 2 is the same as this distance here. Because it's going down, z is -2. Going back to our y-axis, you can see it cuts at 6, so my y is 6. Going back to my x-axis, it cuts at 3. So the coordinate E is given by x is 3, y is 6, and z is -2. Have a go at doing F up here on your own. So your first step was to measure the length here and see how it corresponds to our z-axis, and you should have got that z is 3. So if I come back to my z-axis, this length here is the same as that length there. Going back to my y-axis, I can see that y is -6. Going back to my x-axis, I can see x is -3. So F is given by -3 for x, -6 for y, and 3 for z. Now what we're going to do is we're going to plot points, and hopefully by identifying points it will help you with this, because you're going to have to get your ruler out and you're going to have to make sure you're drawing lines parallel to the axes that we have. So let's start with G. So I need X is 8. So X is 8 down here, and I need Y is 4. So what I need to do is I need to draw a line from 8 that is parallel to my y-axis. Okay, so you can see this line drawn from 8. Now, the best way to make it parallel is to start your ruler at your y-axis and then draw it back. So pull it back until it's at your 8 so you can get that parallel line. Now we need to draw a parallel line through y is 4 parallel to the x-axis. So you can now see those two lines. What I need to do now is look at z equals 2. So I need to measure up the equivalent of 2 units on my z-axis. So get your ruler, measure on your z-axis from 0 to 2, find out what that is, and then measure up that same distance or that same length from this point of intersection of the two lines. So once you've done that, draw your dot for your coordinate and label it. So this is the point G, which is 8, 4, 2. Try and do the same thing with point H. So H, X is 2, which is there. my y is -4, and my z is 0. So I just need to draw my two parallel lines, one through y is -4 parallel to my x-axis, one through x is 2 parallel to my y-axis. Because my z is 0, where those two lines would meet will be my coordinate. So my coordinate is there, and label it h 2, -4, 0. Now try your final one. So x is -4, y is 4, and z is -1. So x is -4, y is 4, and we're going to have to go down 1. So let's draw our lines in. So you can see where those two lines are intersecting. Now I need to go down the equivalent of 1 unit on my z-axis. So I need to measure that on my z-axis and then translate it across to this coordinate. Okay, so I've drawn my point in, and now I need to label it. I'm just going to move this y equals 6 so I can fit it in. So this coordinate is I, -4, 4, -1. Now let's look at terminology surrounding the three-dimensional coordinate system and introduce vectors. First of all, you should remember from two-dimensional that standard unit vectors are the vectors with a length of 1. So looking at this diagram here, my unit vector for I as a coordinate is 1, 0, 0. And you can see that at the point A. So therefore, my vector OA is equal to I. Now for J, the coordinate would be 0, 1, 0. So therefore, my vector OB is a unit vector J. And for K, my coordinate is 0, 0, 1. So therefore, the vector OC is given by the unit vector K. So just remember the unit vector I is in the positive direction parallel to the x-axis with magnitude 1. The unit vector J is in the positive direction parallel to the y-axis with magnitude 1. And the unit vector K is in the positive direction parallel to the z-axis with magnitude 1. Now, terminology, component Cartesian form. Firstly, the coordinate we've dealt with, that will be our x, our y, and our z. In terms of a column matrix, we could write it as x, y, z. In Cartesian or component form, we could write our vector as x, I, plus y, j, plus z, k. Now, you won't always see the ijk written in unit vector form. You will often see it written as xi with the tilde underneath, representing that it's a vector.